Okay, welcome folks. This is Foundations in Pre-Calculus Math 10 with Mr. Johns. We're doing the last section of Chapter 4, which is Roots and Powers. And this is Section 4.6, Applying Exponent Laws. So there's all these special exponent laws that we use, and I made a chart here just to summarize them. So I'll go through it, and then we'll use them to do a few examples. So there's what's called the product of powers. So we have a to the m times a to the n. And notice it's the same base, a. And in this case, we add our exponents. So if I had 2 to the power of 3 times 2 to the power of 4, that would be like 2 to the power of 3 plus 4, which is equal to 2 to the power of 7. Quotient of powers. So here I have a to the m divided by a to the n. And in this case, we subtract our exponents. So if I had 3 to the power of 5 times 3 to the power of 2, that would be like 3 to the power of 5 minus 2, which is 3 cubed. The power of a power. So a to the power of m, all raised to the power of n. In this case, we multiply exponents. So if I had 5 squared to the power of 4, this would be like 5 to the power of 2 times 4, which is 5 to the power of 8. The power of a product. So a times b to the power of m. The m applies to the a and the b. So it's a to the m times b to the m. So if I had 7 times 3 squared, this is like 7 squared times 3 squared. Sometimes there'll be variables and such mixed in, but the laws still apply. The power of a quotient. A over b all to the power of m. And in this case, we'll have a to the power of m over b to the power of m, where b is not equal to 0. So if I had 2 over 5 to the power of 6, this would be like 2 to the power of 6 over 5 to the power of 6. And the power of 0, anything to the power of 0, x, 1, 18, anything raised to the power of 0 is always equal to 1. So 329 to the power of 0 is equal to 1. Okay, let's try a few examples. Example 1. We have 7 cubed times 7 squared, all to the power of 5. So there's two laws we need to use. The product of powers first, and then the power of a power next. So the first thing I'll do is 7 to the power of 3 plus 2, all raised to the power of 5, which is 7 to the power of 5, all to the power of 5, which is equal to 7 to the power of 5 times 5, which is 7 to the power of 25. And this is simplifying by writing as a single positive power. In B, we have a lot going on, but we just need to stick to our exponent laws. Careful with negatives and such. So 1.3 to the power of 2 over 1.3 to the power of 5, all raised to the power of 3. So this will be like 1.3 to the power of 2 minus 5, all raised to the power of 3. Oh, this should be 1.3 here. I made a mistake. And here I will do 1.3 to the 7 plus negative 2. And then here I have to the power of 3, so I'll subtract 3 using the product of powers and the quotient of powers. So I have 1.3 to the power of negative 3 times 3. 2 minus 5 is negative 3, all raised to the power of 3. And then 1.3 to the 7 plus negative 2 is 5, minus 3 is 2. So 1.3 to the negative 9 times 1.3 squared. And here I'll add exponents, so 1.3 to the negative 9 plus 2, which is 1.3 to the negative 7, which has a positive power is 1 over 1.3 to the power of 7. We did it. Now let's do question C. It says your turn, but I think I'll do it with you as it's quite tricky. Just because there's rational exponents, we still need to follow our exponent laws. So we have 5 to the power of 1/3 over 5 to the power of 2/3 times 5 squared. So here, 5 times 2/3, I'm going to add squared. But I need a common denominator, so I'm going to think of 2 as 6 over 3. And this is all to the power of 3. Then I'll have 5 to the power of 1/3. 2/3 plus 6/3 is 8/3. So I will subtract that on top. And this is all to the power of 3. So this is 5 to the power of negative 7/3, all to the power of 3, which is 5 to the power of negative 7/3 times 3. 3 over 3 is 1 over 1. So now I have 5 to the power of negative 7. And this is equal to 1 over 5 to the power of 7. Sorry, I got a little squish there. So that's it. Let's try example 2. Here we have coefficients, letters, and exponents. So in this case, I have 2x times x to the power of 3 times 7x to the power of negative 4. So 2 times 1 times 7 will give me my 14. Then I have x to the 1 plus 3, because this is multiplication, and now plus negative 4. So in this case, I have 1 plus 3 is 4, plus negative 4 is 0. So 14 to the power of x, 14x to the power of 0, which is 14 times 1, which is 14. Because x to the power of 0 is equal to 1. B. 3 times 4 is 12. A to the power of 4 times a to the power of negative 2. I'll take 4 plus negative 2. And this is all squared. So 12a squared, all squared. Now be careful, because this square applies to 12 and to the a squared. So this is 12 squared times a to the power of 2 times 2, which is 144 a to the power of 4. And that's it. Okay, C. 12 over 3 is 4. T to the power of 5 over t to the minus 3. So minus negative 3. All to the power of 1/2. So here I want to add the opposite, and I get 4t to the power of 8, all to the power of 1/2, which is 4 to the 1/2 times t to the 8th times 1/2. So this is like 4 squared, which is 2. T to the 8 times 1/2 is t to the 4th. And there we go. So, your assignment is section 4.6, numbers 1 and 2. There's not too many questions because we're going to do the chapter review next. Good luck. Let me know if you need help.